So back here you'll basically see the setup for the tension and standing wave lab. We've got a resonator right here that's just plugged in right to the wall. It's just a very simple solenoid, which you'll learn about at the end of the year when we do magnetism. And what it does is it causes this little piece of metal to bounce up and down.
Sounds like electricity.
Yes, it's electric. Sounds like electricity. It is. So it's bouncing up and down at 120 times a second. So you have a frequency, you have a set frequency. And then the ring stands are in the usual place over there. And these universal clamps are also in the drawer over there. So you're going to set up this general idea. And you're going to tie a string, make a loop on both ends. You know when you put a string through a loop, it tightens it up. So make a loop on two ends of the black string over here. That way we're all using the same type of string. And it goes down, down, down. It connects to the ring right here. You see how it's like perpendicular too? So it's like bouncing like this. We want it to bounce like this. Okay. And it goes down, 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 down over a pulley with a weight on it. So the pulleys are these bad boys. So you just set it up like this, and then the string is going to go over the pulley, like so. And what do we know about the tension on both sides of the pulley? It's equal, right. So we have the same tension here as we have here. So if we know the weight of the mass hanging from the pulley, then we know the tension in the string here.
Which means you know the tension in the string there.
Which means we know the tension in the string here. So what you're going to do is you're going to plug it in. Okay, first of all, this gets really hot. Okay, I'm just going to mention that right now. If you leave this plugged in all period, this thing's going to get extremely hot. So what I recommend you do is unplug it between tests.
Okay.
So you're going to plug it in. Oh, and there's also extension cords right over there if you can't reach an outlet. There's extension cords you can use right there, but this is just the best setup. So plug it in. And what you need to do is you need to move this back and forth until you get a good standing wave set up. Now realize when you move it towards the pulley, the tension is going to be a little different than when it's not moving at all. So once you get a nice standing wave set up, then you're going to measure the wavelength.
What?
Now, do you measure one hump for one wave or two humps for one wave?
Two humps.
Two humps. So you just, as best you can, measure two humps, then unplug it, and change the tension. Okay? Add a new mass, that changes the tension, and do it again. Okay, so far so good? So measure your two humps for your wave, change the tension, and then all that information we're going to use to find how fast the wave is traveling through the string. Make sense? Now, the formula we have to use is linear density, which is mass over distance, not mass over volume. And to do that, it's really simple. You just take a bunch of string, measure how long it is, and then put it on the balance. Simple. Okay? Questions? No questions? You got this? All right. So, resonators are right there, pulleys are right there, extension cords are right there. Go ahead.